Okay, so welcome to Unit 3, Lesson 2. On the previous lessons, we've looked at some related rate problems, and we will continue to look at related rate problems in this section as well. In this section, it gets a little bit more complicated. So let's begin with a common problem that we see often, and it's an inverted circular cone. And we know that the cone has a radius of 2 meters. So what I want you to see is that as the water rises in this cone, your radius will change depending upon where you are. So the radius, this radius, when it talks about a base radius, that's this radius. And the height is this height. But notice at this particular point, the radius is different and the height is different. So depending on where we are on this cone, the radius and height are changing as the cone increases. Both the radius and the height are changing as water is added to the cone. That's an important thing to recognize here. But what we do want to see is that the radius, this base radius is 2, and this base height is 4. Now, we can use similar triangles. I'm just going to start by doing this, to compare the height of the radius to the height at any given point. So this radius is 2, and this height is 4. So the radius at any given point, let's call it R, and the height at any given point will be called H. So if you recall from, I can't remember when they teach this, but similar triangles, we can say 2 is to 4 as R is to H in this particular case. And so I just want you to hold this over here for a second. Hold this piece of information. Let's see the other information that we're given. We're told that the water is being pumped into the tank at a rate of 2 meters cubed per minute. So the volume is changing at 2 meters cubed per minute. And they want us to find the height, the rate at which the water level is rising. So that would be how high the height, how is the height changing? So we're going to call that dH dt, and we want to know that when H is 3. Okay, so we need to find a formula that's going to represent all of this. And the formula that we're going to use is the formula for the volume of a cone. Now, again, you will probably not be given this on any type of test, so you need to know this formula. Okay? So, the first thing I want you to see is that if we were to take the derivative of this, because we're given dV dt and we're looking for dH dt, and since this is called applications of derivative, it's probably a good idea to take the derivative. So I'm going to take the derivative of this, remembering that 1/3 pi is a constant. So I have dV dt is equal to 1/3 pi. I'm going to go ahead and pull that out. And then in order to take the derivative of this, I have to use product rule. So this would give me, I keep r squared the same, and then I have dH dt plus 2r dr dt times h. Now, what I want you to see here, in order for me to do this, I need to know dr dt and I need to know r. In order to find dH dt, I'm going to need dr dt and r. I could possibly find r from the information that I was given, but I have no way of finding the rate at which the radius is changing. And since I can't find dr dt, I'm sorry to tell you that I'm actually not going to use this formula, because I can't find dr dt. So I am not going to use this formula. Okay? So let's go back to our original formula, which was V equals 1/3 pi r squared h. Now, what if I could eliminate one of the variables so that I wouldn't have to use product rule? That would be a pretty neat thing to do. So I want to eliminate a variable so that I can do this without using product rule. So what I'm going to do is I'm going to go back to that similar triangle that I drew earlier here. So in this similar triangle, what I can find, since I'm trying to find the h dt, I want h in my problem, but I want to get rid of this r, so I don't have to worry about dr dt. So I'm going to solve for r in terms of h. So I get that r is equal to 1/2 h. So in this equation, I'm going to use the system. I'm going to replace r with 1/2 h. So this becomes v is equal to 1/3 pi. R is 1/2 h. Multiplying this out, I get v is equal to 1/3 pi 1/4 h cubed, which I can write then as 1/12 pi h cubed. Now, when I have this, I can now take the derivative of this. So the derivative with respect to t is 3/12, which is a fourth, pi h squared dh dt. And now we have all the information that we need to find dh dt. So we're going to just plug in what we know, or substitute in what we know. So we're going to come back up here, and we know that dv dt is 2 meters cubed. So dv dt is 2 1/4 pi h. We were trying to find this value when h is 3, so we have 3 squared, and we're trying to find dh dt. So solving for dh dt, I multiply both sides by 4. I get 8 equals 9 pi dh dt. So dh dt is equal to 8 over 9 pi. And what units were we given? We're given meters, so this is going to be meters per minute. And this is our answer. Sweet little answer. Okay? So that's it for video 1. Please watch the next video.